Hi everyone, welcome to the eViews demonstration. Now I'm going to demonstrate to you how to um, estimate the vector error correction model. Now, what I should emphasize here is that all the steps are similar to what you do under VAR. In other words, you have to go through all the steps that you go through under VAR. So the first thing that you do is you obviously have to make sure that all the variables are integrated of the same order. So meaning they should be either integrated of order 1 or integrated of order 2, whatever the case might be. It is usually not advisable to have variables or to estimate variables that are integrated of different order using VAR or Vecm, because we know that what the model that deals well with that is the ARDL. So now, once you once you test for unit root test and you um, test for um, uh, lag length, you test for um, stability of the model, you test for all those diagnostic tests such as the autocorrelation, normality, um, uh, what else? And then heteroscedasticity. So now, once you actually find out that all these conditions are met, then the next thing is obviously to then test for co-integration. So now, I'm actually now assuming that, of course, here I've tested these variables that they are all integrated of order 1. So here we are going to look at the relationship between interest rate and credit. Obviously, theory tells us that there is a negative relationship. In other words, if interest rate goes up, then obviously credit becomes short in the market, because if the repo rate goes up, then that means that it's very costly for commercial banks to borrow from the central bank, and so therefore it means that commercial banks have to up the lending rate, and so therefore it becomes costly for consumers to actually borrow from the banks, and that's why where that is actually where the negative relationship is coming from. So we are going to look at how interest rates affect um, what you call it private sector credit. So let me just quickly open this SFR. Obviously, we know that for you to go through all those tests, you open the first you open the MSFR and you do all those tests and all those diagnostic tests. Um, but let me I just want to check something. I just want to check if this var will be stable. So we have seen that the var is stable, and so therefore it is fine. So now we can just go ahead and test for co-integration. So if you have tested all the other, from unit root test, lag length, lag exclusion, the diagnostic test, heteroscedasticity, normality, and autocorrelation, and then the VAR stability, then the last step is that of testing for co-integration. Again, you just go to view. Of course, this is where you do all your other tests, as you can see them. If you remember from the VAR lessons, the residual test where you do your autocorrelation, normality, and then heteroscedasticity. So now then here you just do the co-integration test. Now another co-integration test, you don't have to you don't have to change anything. You just click on OK. Now let me just enlarge this. You can remember that in the lesson I did indicate that you have two tests. You have the trace statistic test and you have the maximum eigen. So with the trace statistics, you have the calculated value, you have the critical value. For example, here you can basically see that this value of 19.24 is greater than this value of 15.49. So, and then it actually, usually the EVs will even indicate to you with an asterisk that how many co-integrating equations are there. And you can even see it's written here below. Trace test indicates one co-integrating equation. And then again, if you come to the maximum eigenvalue, you can basically see that this value of 16.50127 is greater than this value of 14.26460, and so therefore also the maximum eigenvalue does indeed indicate that there is one co-integrating equation. So seeing that there is only one co-integrating equation, so we can actually then go ahead and estimate the vector error correction model. Okay, so now what I want to, of course, let me just quickly check what is the lag length that is uh, suggested by this model. So it says we should use, if we use the SC, we use the lag of 1. So actually, usually when the lag is 1 or 0 or 0, 1 or 2, we usually really don't, I prefer not to change anything because usually that is the default lag. Okay, all right. So I just go back, test for co-integration, then we see there is co-integration. So now all we can do is just estimate the vector error correction model. So what we do is now we click on estimate here, and then instead of choosing standard var, because this is your unrestricted var, we now just choose the vector error correction model. Okay, and we don't have to change anything here, we just leave it on the default lag. But suppose the lags were 4 or 5, yeah, suppose the suggested lag was 4 or 5, then we were going to change this, but now that it's suggested as 1, we just leave it on the default, and so therefore we just click on OK. So now once we click on OK, now this is the output that I was referring to. Okay, so now it even tells you vector error correction estimates, and then you have, of course, if you cannot remember what the dependent variable is, usually this will tell you, because it tells you the vector here is 1. So it's 1 because this is the coefficient, this is the coordination of the dependent variable on its own. Okay, so remember we are looking at how interest rates affect um, uh, credits. So now remember I did say that if the variable appears, since this is a vector, if the variable appears to be positive in the vector, so you have to interpret it as negative, because that's actually what it means. So for example here, it basically actually then tells us that um, if interest rates, say for example, increases by 1%, then private sector credit will decrease by about 24 or about 25%. Okay, that's basically what it means. All right, so yeah, so and then of course this is your long run section, and this is your short run section, and it even tells you error correction. Okay, and it tells you co-integrating equation. This is basically your error correction term. So the coefficient of the error correction term here is 0.29, so meaning it takes about 29.4% for this variable to converge to their long run equilibrium each quarter, and we can basically see that it's negative and it is statistical significant. Now, probably you would now come here and say, okay, but what about in the next question? Here we are, um, uh, here the coefficient basically tells us that um, private sector does interest rate does help in bringing private sector to its long run equilibrium value. So of course, but now you can see here, now of course the next question would be, why is it that this value is positive? It's actually not positive, it is negative. It's just of course there is a paper that I could actually share with you how mechanically it's done. Of course, in some school they would actually teach you to say, no, this is positive, but it's not positive. If you actually look at the manipulation, the mechanics behind it, actually this value is actually negative. It's just that because it's just that in e-views now it's made in such a way that now when this comes out, it doesn't come out as negative like for the rest of the co-integrating equation as it appears in the single equation, because in the single equation everything comes out as it should have come out as negative. All right, so therefore this is basically what how you estimate the vector error correction. So you can just highlight this is basically the part that you need to highlight. So in other words, you don't need the rest of the output, and then you copy that and then you paste it, and then if you are interested in seeing how the shocks are, you can just go to view impulse response. If you're interested in that, then you can see impulse. You want to see how if you shock interest rate, you want to see how private sector will respond. So you can remove, you can leave private sector under response here. You can increase the quarters to 24 since it's quarter. Then you click on OK, and you can get your, you can get the, you see here. So you can immediately see that private sector, it's a high jump. Then immediately after how many quarters, I'll just do that once I minimize it. You can basically see that it actually formed a new equilibrium. It formed a new equilibrium, so meaning that the shocks in the interest rate was actually permanent. Yeah, so basically after almost 7 quarters, then a new equilibrium was formed, and then you can see the decline, in private sector. And that's why we say the effects of policies it always happens with, like, it doesn't happen immediately or instantly. And so therefore, and this also corresponds why it takes about 29 or 24 point whatever percent, for this variable to convert to the long run equilibrium. So this is basically how you do the vector error correction model.